A 15 microcoulomb charge is placed at the origin. What is the electric field at x equals to 5 meters? And if an electron was placed there, what would be the magnitude and direction of its acceleration? The charge of an electron is 1.6 times 10 to the power of negative 9 coulomb, and the mass of electron is 9.1 times 10 to the power of negative 31 kilograms. So the charge is placed here. That's 15 microcoulomb. And we need to find out the electric field right here, which is 5 meters away from this positive charge. So E will be K times Q over R squared. K is Coulomb's constant, 8.99 times 10 to the power of 9. Q is this one, 15. Microcoulomb, I need to convert it to coulomb, so 15 times 10 to the power of negative 6 coulomb divided by R squared, which is 5 squared. So that's going to give me 8.99 times 10 to the power of 9 times 15 times 10 to the power of negative 6 divided by 25. That is going to give me 5,394 coulomb per Newton per coulomb, or 5.4 times 10 to the power of 3 Newton per coulomb approximately. And it says if an electron is placed in this point, what is going to be the magnitude and direction of the acceleration? So since this one is positive and the electric field is going to be this way, and since we have a negative charge in this case, negative charge, the force is going to be experienced to the left. So F will be equal to E times Q, or we can say vector F equals to vector E times Q, which will be 5.4 times 10 to the power of 3 times Q, which is 1.6 times 10 to the power of negative 9. That's going to be 8.64 times 10 to the power of negative 6 Newton. On the other hand, we know F equals to M times A due to the second Newton law. We know the force, we know the mass of the electron, and based on that we can find out the acceleration. So acceleration will be equal to F divided by M. F is 8.64 times 10 to the power of negative 6, and M is 9.1 times 10 to the power of negative 31. That will be 9.49 times 10 to the power of 24 meter per second square. That's going to be the magnitude of the acceleration.